Well, hello, everybody. Welcome to week 15 of safety and construction. I'm glad I'm joined by Mr. Mark Epstein with REM Technologies. We also have Mr. Chris Cantu with St. Mary's University, and Turki Mohammed. He's one of my students from the safety and construction course. And so I'm excited to see this meeting coming up. I know that there's a bad weather right now out there, and so we might have other people joining later in the presentation. And so before I get Mark to talk about REM technologies, I'm having this class being recorded today just for everybody else and for the record. And so I'll begin the class by sharing the screen, which will show just the quick introduction before I take it over with Mark. Just so you know, again, today is week 15, April 20th. Our main topic is drones, and we have REM technologies doing the presentation. And so we have our learning objectives here. This is just a full overview. So we're going to learn about manual drone operations, the autonomous 3D scanning, and then how business operations are run over by REM. And so as far as today's schedule, we have the first part of the class, the presentation with Mark Epstein, and then we'll have a break, and then after we return, we'll do exam number 4. And so if you can stand by, that'd be great. Just for the record too, since we have a bad temperature, in the event that the signal breaks or the internet just comes down, then the MO is to return exactly 10 minutes after it has come down. If things get bad, then we'll have to do this lecture at a different time. And then if everything goes as well, then we already know the schedule. So without much further ado, if you want to go ahead and take over, Mark, from here.
It's a pleasure to meet you all.
Okay, I went ahead and gave permission, Mark. So let me know if you're able to share your screen. Mark, I can't hear.
How about now?
There we are.
You can hear and see?
Now I can, yeah.
Success. Wonderful. All right, Juan. Well, thank you. Thanks for having me, Juan. And also thanks to St. Mary's for having us. Really excited to be here. Again, Mark Epstein with REM Technologies. Building relationship with St. Mary's as we speak. And as a result of that, we'll have our first intern this summer because of St. Mary's University. So thank you for that, Chris and Dr. El Capo and St. Mary's all together. So very excited about that. You can still see? All right, I believe so. So I'll go through an agenda here real quick. It looks like a lot, but I'm going to burn through the first few slides pretty quickly. And most of that is kind of describing what VDC is and where drones fall in the virtual design construction world. And then we'll get more specifically into drones. Quick introduction. Again, my background is in architecture, a master's of architecture and a master's of construction management. When I finished architecture school, I went directly into the construction side because I like to see things being built and put together. Eventually I got my architect hours in the build side, so I had to get into design. Eventually moved to Austin, Texas from St. Louis, where I'm originally from. Worked in Austin for 5 or 6 years and then moved to San Antonio about 4 years ago, where I then went back to the general contracting side. While I was in Austin working for the big architecture firms, gave me a really good opportunity to see technology and just the tip of the iceberg of like how far it could be taken. As architects, we were using a backbone program called Revit, which is basically what everybody designs in now. But we weren't doing much with the model beyond like producing drawings. But I could see on the contractor side that we're doing really exciting stuff with the models and just the rest of an entire universe of technology that typically in the design side we don't get to do. So about 5, 6 years ago, I made the change back over to the GC side and moved to San Antonio. So happy to be here. And so, yeah, but really, the GC side is where my passion is. Being able to get my hands on all of these things like BIM. Hopefully y'all have heard of BIM, 4D schedules, 5D animations. You're linking costs to time and 3D models, laser scanners, HoloLens, and of course drones. And eventually led us to, it was early pandemic. It was probably pre-pandemic, 2019, early 2019. The two other partners and myself were operating in silos and came together over a beer, and we were like, I've got this idea. Kenny said he had this idea. Carl said he had another idea, and they all like aligned perfectly in space, just at different points of the universe. So really exciting how we came together. We've been operating since 2019. We were kind of in the closet on paper for about 2 years, and then recently come out of the closet and actually in the functional productive world to where we're doing something in the world and not just on paper. So it's been a journey for sure. So some quick learning objectives. I won't read all of my slides to you. I know that drives me nuts when folks do that. So you can just skim through them, but we'll understand how the drones fall in VDC. We'll talk about what it means to fly commercially. We'll discuss some safety analysis, and that will also be pertinent to the inspection topic. And then obviously some basic terminology, and we'll go through our user interface where we produce our deliverables. I'm realizing I have a watch on my wrist, so there you go. Yeah, so get excited. I'm not sure if y'all saw this video. I'm not going to play the whole thing, but this is from Skydio, and this is their autonomous system. So typically, this is how they do bridge scans. They hang a truck with a bucket over the edge, and they do these bridge scans. And it's really pretty dangerous to do this these days. And so they've developed this system to where it can autonomously sense objects like bridges, anything you see here, different utility lines, and it knows not to hit it, right? So it seems pretty simple, but this is the only drone on the market that does that. Everything else relies on what's called as a magnetometer. So basically what's in your phone that connects to GPS, pretty similar stuff. This one does not do that. And in that, it's very unique in the market. So I won't play this whole thing. It is a pretty great hype video for sure. But it's not widely available in the market. But we got into it early, about 2 years ago, and I'm pretty excited to be part of it. So right now we've done a lot of experiments with it. We've done some small jobs with it, but my next hope is to tackle a full-scale bridge scan with this. So what that scan would create is a 3D model. Then we pass that down to engineers, and they would use it in a way that they can understand what a level 4 crack is in concrete and what that repair typically costs and how much time is typically associated with that. So you're building a whole estimate based on a 3D model in which you didn't have to have anybody hanging over a bridge for a number of days or weeks, but we did it in a day. So pretty exciting technology for sure. I will end that there, and we'll keep moving on here. So as I mentioned, virtual design and construction, it's really just a collection or a universe of hardware and software being used in the construction industry these days. So If you've ever used Revit or even AutoCAD is in there, it's at a very basic level. Revit's more of a 3D level of that. And also you've got laser scanners, drones, really any digital tool that's helping you build the project and be more efficient, whether it's in pre-con, you can be in ops, but you're getting more efficiency out of that tool at a level that we've never seen in our industry before. Auto industry, lots of other industries use similar tools, but it's kind of all coming to the forefront for construction lately. So BIM is building information model. And so basically that is your 3D model with embedded data and components in it. So back in the day, you would, you draw pen and Mylar, right? And then there was CAD, but those CAD lines don't have any data in them. They're just lines. So in Revit, you draw with walls. So you've got your structure and your waterproofing and your substrate and your finish. You've got everything in there. And that data is carried from the design side over to the build side. And there's just a world of information on what you can do with that. So the BIM Festo, as nerdy as it gets, I promise, is really, we're just trying to make more informed decisions earlier in the process of construction. If you can resolve issues earlier in the project, in the process, it has less of effect on affecting budget and time downstream, and that's always best. So yep, mention this. So you can see way down here in the far right corner, there's a wall and it's highlighted and it's blue. And so just that tiny one component on this, I don't know, $80 million project can tell you a huge amount of information about the project and based on that wall type. And then you can see here it's stripped down to the systems. You can see those MAP systems and structure systems stripped down. So just a quick glimpse into models. We won't talk too much about those. This is actually the same building though. And another component of VDC is 4D schedules. And a couple of things here. One, basically we're marrying the P6 schedule with the BIM model. And the thing I like about this is nobody likes looking at Gantt charts. At least I don't think so. I don't. I've looked at a 36-page Gantt chart for too many hours. And what this does is basically it visualizes that Gantt chart and it shows you, let's say that we've got third floor structure coming in before first floor structure. Well, obviously we're not going to build it that way. And somebody just made a wrong click in their P6. But let's get that figured out here. And so that might change things in the front end of the schedule. So a quick thing that I wanted to show you, this is a good example of a 4D model. Oops, let me put that sound. You got your structure going in. You can also include your site logistics, much like we do here with the crane tower. It's so high that you can't see the top of it. You can include safety aspect, like we do the deck barriers. We've got our material lift. I'm going to skip this forward a little bit. And then you start to see the different levels of building come in with the facade and everything else. So typically these are on the exterior, but we've also done them on the interior as well. I think, no, that might not be this video, but this is a great tool to give a client a good visual of their project in time. And we'd also typically have like a schedule bar across the top or bottom of this, so they could know, okay, at this time, July 2025, we're almost topped out and we're halfway skinned or whatever the case might be. So a really great visual communication tool across the board. Another one of those, this is a bridge translation where we basically got an existing bridge over, if you've ever been to Arizona, every creek bed is dry, every river bed is dry. We're going to build a bridge next to it, and then we're going to put the new bridge in place of the old bridge, which is a pretty gnarly process. But again, right, if you're telling a client that, they're like, what? So this is how you show them that you're not completely crazy when you put that structure in. Sped up here a little bit. And the orange is the existing. So we're going to remove that and then do what they call a bridge translation and just bump the new over in place of where it was. It speeds by really fast. There it is. So again, a great visual tool. And then, yep, we'll come back to that one. So that's 4D schedules. We'll move on. Laser scanning is another really popular one right now. You can scan your existing conditions and understand how the design model is supposed to fit into the existing. So if you're familiar with downtown San Antonio, this is the Hilton Canopy Hotel, the big hole is. This is the tavern. I always forget the name of the tavern, but they've got a really good old-fashioned there. So 80-year-old, well, I'm not sure what happened there. An 80-year-old masonry wall here. We obviously don't want to touch it. We don't want to move it for sure. We definitely don't want it to fall down. So we started, I lost my thing here. We started by laser scanning that. Bear with me here. Started by laser scanning that. And so this is that wall looking from the other direction. And so this is a little bit of a tutorial here. But that laser scan is going to pick up every nook and cranny on that wall. And we don't really care about every nook and cranny. We just care about where the wall is generally. And I'm going to speed this forward here. And how that works with our designed BIM model. So that's going to come in here in a moment. Now you're looking north. St. Mary's is to your right. St. Mary's, South St. Mary's, North St. Mary's. So this is the building and just a couple floors of it because it's a giant model. But you can see that 18-inch gap between the existing and our proposed. And so we always want to be aware of where we're proposing to put components. And as you see, we're going to walk down this void. We get close to the back there. There was a component that was designed to go in the middle of there. That green box. So we eventually figured that issue out. But lots you can do with laser scanning. Check existing conditions. You can confirm QA/QC. A lot of clients, sophisticated clients, are requiring this for as-built documentation, which is kind of an expensive way of doing it. But laser scanning is getting cheaper and cheaper kind of all the time. And then we wrap this up at the very end. Bear with me. A little bit of a flyover. And we overlay that with the drone flight. So you can see our hole here, our giant drill rig, and the tavern here, and the river walk down there. And so really taking, and this is a good example of virtual design construction, putting all those tools together and making sure that we're checking forward, backward, and upside down, if you will. So I'm going to go back to this. Another one is augmented reality. Yep, we're good. Where I've got this silly headgear on, but basically it takes that BIM model and it projects it in the goggles while you're on site. So here we're looking at some, what are these, switches or outlets? I think they're switches. And you can see the gray fuzzy boxes. That's where they're designed to be. And they're actually installed a little bit off, which probably wasn't a big deal. But the more interesting thing here is the quantity. And we've got 3 boxes designed and only 2 installed. So this is the time to catch this stuff before it's encased in drywall. So a good catch there. Cool. So finally to drones and what y'all are here for. Before I go any further, I don't want to talk so fast that we don't have time for questions. Does anybody have any questions so far about what we've seen? All right.
Yes, I do have questions. In the beginning of the presentation, you mentioned that there is a standard equipment used to build a bridge. And in the best year, one of these bridges fall down. So why they use this heavy stand equipment to build a bridge when they know that somehow it will fall down in the future from first place?
You know what, my friend, you were asking $1 million question, and like everything you're asking is perfect. I don't know. It's crazy. Those trucks, you cannot imagine. Those are $750,000 utility trucks, and they tip over more than you would expect in the 21st century. It's crazy. And so,
yeah, sure.
The drones aren't cheap, and the technology is not cheap, but it's definitely cheaper than a human life, and it's definitely not $750,000. So I'm putting two and two together here, and it's like you don't need that truck, and you don't need the risk, right? The risk is the part that I am blown away by. This is still a common practice today, and as they talk about, you know, a crumbling infrastructure in our country, you got to expect it. You know, these bridge inspections are going to be more and more common. I mean, they're common. They're just doing it in a very archaic way. So really hoping for that for that part of our business
Yeah.
to take off for sure.
Thank you for your explanation. And the second question, so in the back two slides, you explain how they build, you know, the bridge, but it wasn't clear because I think I have a, you know, Wi-Fi issue. It goes on and off, and I didn't see it clearly. So can you just go back and
the bridge?
Oh, yeah, go back.
Yeah, bear with me. And here, let's go back to here. Here's the bridge translation.
Yes.
So all this, and I didn't mention this gray transparent, this is actual drone data. It's 3D topography. So it's a very shallow sort of dry riverbed. Again, they're very common in Arizona and other desert-like places. So what we've got here, and the yellow is their temporary construction road down through the bed. And the orange is the existing. And so basically they're going to build a bridge to the right, which is what you see going in green. They're going to build one on the far side on the left.
Right.
And then they're going to get rid of the middle, the existing, and bump the new over so they're together.
That's smart.
The existing's gone. Yeah, but if you're a client and I'm telling you we're going to build a bridge and then move it, you're thinking I'm nuts, right? And so we slow it down here, translates over. So that's what they call the bridge translation. How about that? Was that better?
Yeah, thank you for
great. All right. All right, we'll keep moving on here, y'all. I don't want to take too much of your time. So drones, as you can see by this slide, they come in lots of colors, shapes, sizes, lots of price points. I know y'all have your drone lab on campus. I visited very, very early pandemic when Dante was still here. A gorgeous facility. We do courses up at Texas A&M, and they don't have anything close to what y'all have. So consider yourself lucky. Go over there, check it out, see what they're doing there. Pretty cool stuff. So a little bit of regulatory stuff, kind of on the boring side, but definitely necessary when you're flying for any reputable client or company. I won't go into our process here. The point of this slide is that it can be a process. You got to understand who you're flying for, understand where it is, and we'll get into the safety stuff. All to say is it's a process. And then again, some key policy that I won't really get into, but just making sure really comes down to communication, right? Downtown, if you're flying next to hotels, make sure you're talking to the hotel managers and letting them know, hey, we're flying tomorrow between 10 and noon. And so when he has 15 guests come down complaining about a drone peeking in their window, he's like, no, I understand what's going on. Not a big deal. So communication is a huge part of the policy. Understanding, you know, the time allocated to rush with drones on the job site is never a good idea. So just plan for it to take some time and be okay with using that time that way. Depending on your system, there's a cost. Always understand that. So all to say, we are not, I lost it, sorry. My monitors are set up different than they usually are. We are not flying like this guy is. So I show this sort of jokingly. This is one way to fly a drone. And this guy actually won a drone video award, I think in 2018 or 2019. I forget when. Oh, maybe it was longer than that, 5 years ago. Yeah, because resolution's not that great. But he flies through this bridge. He flies into one of the cars of the train. At one point, he flies under it. Right, like this is quintessential, not at all what we're doing on a job site ever. So I won't show that. You can look that one up. It's entertaining though, for sure. So some of the necessities when you're flying commercially, which is anytime you're flying for profit, whether it's for you, for your employer, anybody, it's considered flying commercially, and that requires you to have an FAA Part 107 license, obviously administered by the Federal Aviation Administration. They'll send you through a series of questions. I just did my reoccurring, a month ago. You got to retake it every 2 years. And that was my second time retaking, so third time overall. First time's a little bit more in depth and detailed, and the second two were a little bit more abbreviated. But it will test you over a lot of safety things that you might not expect. So I highly recommend going through the course, whether you're flying commercially or not. And some of those necessities are a big part of is understanding our national airspace system. So anytime you jump on Southwest and you're going up to Dallas or New York or wherever, this is the airspace that you're in, and this is how it's operating. So you've got A, B, C, D, and E, and G. Typically, we like to fly in E because there's not a lot of restrictions. And then when we get to A, you're right next to, I'm not seeing it. Yeah, you're right next to big airports, right? Or something big. And so I won't get into the details of that, but there are flight restrictions. There's weather resources you got to be aware of, and of course, emergency protocols that you definitely have to know. And then there's sectional charts, which looks to be the most confusing thing maybe you've ever seen. It was for me the first time I looked at it. But every color, every line, every type of line, every letter and size of number on here means something different. And unfortunately, you do have to know it for the exam. However, on a daily basis, flying our modern apps simplify this greatly. So this is the DFW area. And as you can imagine, there's all sorts of restrictions there, but this is way easier to read than the previous slide. So typically, we're restricted to fly 400 feet and below. And that's what these numbers here mean. If you're flying on the airstrip, obviously you can't do that. That's a 0-foot elevation of ceiling. But as you get further out, let's say way over here, top left, then they're letting you know, okay, you're good at 400 feet. And then if there's not a number, then you're also good at 400 feet or below, right? So it's a ceiling. And as you get closer to that airstrip, it's a lower and lower and lower ceiling. There is a new application on the drone deploy interface where you can request this LANC, which is low altitude authorization and notification capability. I have the acronym written here because I can never remember it. But basically that's an instant authorization to let you fly, probably not right next to the airstrip, but within these zones somewhere. It can give you automatic authorization. Not every area is operating with the system yet. It's been implemented maybe 2 or 3 years now, but definitely better than applying online with the FAA and crossing your fingers for 90 or more days. So a good alternative. The FAA realizes that drones are doing wonderful things and people are going to fly them whether they get authorization or not. So they're trying to meet the industry halfway and evolve with the industry. So this again is that hotel site in downtown San Antonio. Again, this is St. Mary's and this is East Commerce here. And I know you can't read this entire slide, but it's a good slide to show, or a good job site to show with just all the different hazards that are in this site. So on the ground, you've got moving vehicles, which at this time you were not permitted to fly over, nor people. And that's a little bit different now. Again, there's always a waiver for the rule, right? But you have to get hyper specific when you apply for those waivers. You've got the river walk, boats, more people, trees that are higher than you'd expect. You can't see it, but at the bottom of the slide, there's a hotel down here. That's the Drury. And obviously this big orange one's a hotel. Over here's the Aztec, much lower, but still you don't want to run into it. So understanding all the different risks on your job site, and being aware, and always understanding that Just because you can't see it on Google Maps doesn't mean it's not there. Like, say the hospital is 3 blocks away that has a helicopter coming and going intermittently throughout the day. They're not even on schedule, they just come and go. And so you always have to give right of way to that manned aircraft and being okay with that. The time of day, depending on your deliverable and what you're trying to capture, sun and shadows can be a difficulty. So this one, I like to fly it in the morning when the wind was low, but then you got pretty harsh shadows. And so half the job site's in a dark shadow and it just looks like a black hole, and our deliverable doesn't look good. When the sun's high, it looks a lot better, but it's really, really windy, and the wind is coming off a 20-story building right across the street here, and it gives you sheer winds that are a little bit more difficult to predict. So all kinds of things to think about on the job site. But I like to put this together before I hit the job site. So I've got an idea of where those buildings are, where dense people are, and just to understand the job site overall. So we typically use for mapping, mapping is when and I'll show you, taking a whole bunch of photos just straight down, following a flight path much like this, back and forth, back and forth. A lot of folks get really excited about flying the drone with me when they go out, and then they're looking at it, and it's under 400 feet, but it's maybe 800 feet away, and they can barely see it, and they're like, oh, this isn't all that fun. I'm like, thanks, but so this is a flight path, and you can control all these different parameters, right? How high are you? What is your boundary? You can make this as custom as you want. Your altitude, your overlap. So when you're going these flight paths, are these closer or further together, right? Your flight direction, your flight speed, obviously your gimbal is your camera, basically the neck that the camera is on. What angle do you want that at, right? Is it just a flat map that you're capturing with gimbal straight down? Or do you want to catch the facade of that building, in which case you want to gimbal up a little bit? This is just, flying whatever it is, horizontal or vertical, but you could also fly that as a crosshatch. So you could fly the perpendicular direction, and that would just that would up your resolution on your deliverable, and it'd be twice as much, or if not more, data. So more data is not always better, just depends on what you need, right? Understanding that end goal. Then of course there's always custom settings and preview options. The thing I like about the software, though, this particular one, is it tells us then, based on our parameters, this geometry, and what is it, 7 acres, and an altitude of 150 feet, we're going to take 260 photos, and over here it tells us how many batteries. It was probably 1 or 2, but it can calculate how much battery you're going to need. So, and then I mentioned this earlier, the Lance authorization. And it gives you a little bit more details here, but depending on where you are, if you haven't researched the area, or even if you have, let's say we researched it over the weekend and we're going to fly out on Wednesday, great, but you could have events taking place there on Wednesday that you'd want to know about, and this would give you real-time notifications. A super handy tool. All right. Let me pause there for a moment and see if we have any other questions. And we, of course, will have time at the end for questions too. All right, we'll keep moving. I won't describe the anatomy of a drone very well, because what we do at REM, we basically use off-the-shelf tools, whether it's drones, software. We don't build or develop our own thing. We create value for job sites, essentially. If you want to know about how these motors and pieces go together, you go up to the drone lab. Those guys know a lot. Those guys and gals know how all this stuff is physically put together. It's pretty remarkable, the knowledge they have. Some terms, gimbal, we talked about. Nadir is when you're shooting that camera straight down as opposed to gimbaling up. Orthomosaic we'll talk about is pretty primary to what we do, but it's basically just a big map comprised of hundreds or maybe even thousands of photos, and they have a certain amount of overlap. Photogrammetry is just the photos, basically. And thermography is one that we won't talk about much today, but basically taking thermal images. We've had a couple of interesting jobs where we do that. We'll go out and fly a drone at 2 a.m. Okay, so you're flying in the middle of the night. You got to have an authorization for that. Typical license doesn't allow you to fly outside of basically daylight. But we're flying thermal imaging so we can shoot the temperature of the concrete, both as it comes out of the truck and as it's poured, and monitor those temperatures and use that for QA/QC aspects. Very interesting stuff. So drone data, there's a lot of different data and a lot of different uses. These are just a few of ours. We'll overlay. So again, that tower downtown, we would fly those decks pre-pour, right before they pour concrete, but all the rebars in place, the slab penetrations, you know, your MEP penetrations, everything's in place except for the concrete. So if something's in the wrong spot, now's the time to know before it's set in concrete. So we'll fly each deck and then we'll process. It'll take probably, maybe, I think it was taking like 2 hours. It was a pretty small deck. 2 hours of process. Then we get that big map and we overlay in Bluebeam our structural drawings, our penetration drawings, and we basically create another layer and say, okay, do we have everything? Check it off the list before that concrete truck gets there. Now, it's not a lot of time, so we got to be quick with it. And if something's in the wrong place, we've got to be even quicker to fix it. But on a really, really complex project that hotel was 22 floors, we went 22 floors up with no vertical conflicts at all, which is kind of remarkable in a sense that there usually is. It's not that amazing because we're in the 21st century and we should be able to figure this out. And so we did figure it out. But it's not always figured out in time. So again, inspections, I know you guys are mostly interested in inspections and processing, you know, that 3D image, whatever it might be, a bridge, a tower crane, or whatever. Cut fill analysis is a great one. We did one a couple years back. It was with a transportation industry entity, we'll say, and basically they designed the freeway to go this way, and we were building it this way, and they said no, we want to go this way. And we said, okay, fine, we'll build it any way you want, but we need to be paid for this amount of dirt that we moved. And there was a conflict on how much dirt had been moved. Well, it's 7 miles of dirt. It's a lot of dirt. It's a lot of money. So it went to litigation and they went to trial and, excuse me, they went to court over it. And long story short, we went out there and flew it for 3 days. 3 of us got every type of data you can see here and even more. And the court case that was supposed to last months, some in construction last years, it lasted 3 days and it was a $19 million settlement and it was done just like that. So if a picture's worth 1,000 words, we sent him with millions and millions of words. We sent him with 3D data, understanding the topography, the dirt that had changed, and we can measure all of that based on the differences in elevations of the topography. We sent him with video, everything. It was a really great case study for drones and litigation. I'll keep going here a little bit quicker, y'all. On-site planning, again, really great safety tool. You've got an overall job site. Your safety manager can say, hey, look at this corner, like let's clean up the housekeeping, no trips, slips, and falls, amongst a lot of other communication. So flight missions, again, as I mentioned, maps or orthomosaics. I mentioned the 3D autonomous, we'll talk more about that. 360s are just 360 images like you see on Google Maps. We'll talk more about that and how we can do those handheld as well and incorporate that into our deliverable. So we'll see more here. And that's what this is. So this is, we show that back and forth flight plan. Well, this is the result of that, right? After we flew back and forth, I don't know, maybe 45 minutes or so, we ended up with 565 images. And then we send that to be processed in the cloud, and it creates a high res overall of the job site. And so that's what we have here. Yeah, and so that's basically the background for our deliverable. So in the red, you see the hotspots that are 360s, and we'll just go there, hopefully. Yeah. So this is our deliverable. If you're a client, that's how you receive it. You'll receive a link. You've got your overall job site. You've got some strategic 360 images. And then over here in the white, we'll get to those. These are actual floor plans that we've attached interior 360s to. So, you know, if it's during COVID or you're a client in California, but your job site's in Texas and you can't go there every week, this is an awesome deliverable. So basically, you're creating a Google map of your job site, which comes in really good handy. So I want to jump back here. You kind of get the point, and then I don't have it there. We'll go to a plan view. Let me go to the first floor, of which we can jump then into the building. So this is handheld, as you can see my hand there, and a little burnt out because of the intense sunlight coming in here in whatever this was, August or whatever. Oh, March. But then we create this deliverable to where we're basically creating a walkthrough deliverable for our clients, and they can go see whatever they need to see on the job site. It's pretty great. And then last but not least, we've also got a link to the exterior fly-through of that day. So this was, oh, this is a minute ago. Oh no, this is just last year. So this is as they're finishing up the building, asphalt's in, the skin's done, they're just finishing up. So let's kick it along here a little bit quicker, but a huge job site, $70 million project, 75 million. Client again was typically in California. There were a couple of them in New York. But this brought huge value to them and not having to fly to San Antonio every week or every month. So these guys love this. And this is typically our deliverable then, is our orthomosaic background, our 360s, and our video, and everything's interlinked. There are different softwares on the construction technology market these days that do that. I think that they try really, really hard, and it's a very expensive, a lot of them are very expensive platforms. Ours is pretty much free with our service, so I think it's a pretty good deal. I'm a little biased though. Before I go on, any questions on that deliverable? We can come back to it too. Moving on a little bit more. So this here in the top is a good example of flying that floor slab before the concrete's poured and overlaying drawings. So I think in this case, it's architectural drawings, and they want to make sure that they've got their walls in place for their cores, their elevators and cores. This is a good image for the cut fill analysis. So a big mound of dirt, basically. Back in the day, you'd either survey that, or even more painful, maybe go out with a plumb bob. I don't have experience with that, thankfully. It sounds time consuming and somewhat error ridden, but we can fly this in a matter of minutes, process it in a matter of hours or less, and tell you within maybe about 10%. I like to say truckload, but it could be 10%. You know, that'll fluctuate, you know, per the size of the job site. And then down here is another flight path, but you'll notice that's sort of spiraling up in 3 dimensions. And again, this is the Skydio platform, the only one on the market that does that, where basically you set your floor, in this case, the ground, you set your ceiling, which is, I don't know, a couple feet above this tank, and then 4 pins to show your perimeter, right? And so you hit go, and then it goes to examine those parameters and what's in there. What is that object? And after flying through it, it understands where that object is. And it says, okay, we can fly this. Is it on here? This is not the right screen, but 520 photos. Maybe it takes, I don't know, 10 minutes. And then it'll have a model for you almost immediately. It's pretty amazing. So this is great for as-built conditions. Imagine like having a tower of some sort that you wanted to understand the existing conditions, whether you're going to add on to it, or you want to understand, you know, the surface quality and the condition of this tank. A lot of different uses for that. All right, some drone hardware and the drones themselves. So this one on the left is a DJI. They're a Chinese manufacturer. You've probably heard of them. Most common in the world, simply because they're very easy to use, and they're pretty affordable these days. I've got one that looks just like this. I refer to it as my F-150. It's not pretty, but it gets so much work done. So I kind of love it. It's about 6 years old, and it's done great for me. These are fixed wings, it's an entirely different system, much less flexible. You can't do cinematographic stuff with this. This is for flying 100 or a 500-acre site and basically putting a survey together. The good thing about this is it can stay in the air a lot longer. Battery life is much longer. The systems to use this are quite a bit pricier though. So you definitely professional grade here, but not just professional grade, because this can be used professionally as well, but very specific, we'll say, very specific uses. And then you've got a difference between manual and autonomous systems, right? So again, the DJI is great. It's very user-friendly in terms of, if you're a gamer, when we do workshops on campus, like the gamers typically do the best, and it's pretty impressive because the skill translates pretty well. I'm amazed. Again, highly customizable. You can do a lot of different things with it. These have been on the market for, I don't know, 8, 10, 12 years now. So there's a lot of resources and blogs. You can YouTube your problem and you can solve it in 10 minutes or less.
Sorry for interrupting. Dr. John informed us that in order, you need to be registered for drone in order to use it. So what the purpose of using drone, and what do you use it for exactly?
What are we using it for? Okay, good question. So you're capturing data. So you're understanding that job site, you fly that job site, and your superintendent or your safety manager, your engineers on the job site will find endless uses with that image of the job site, because their boots are on the ground. They're not used to getting 200 feet above the building and being able to see what's going on, right? So when you've got that big picture overall, you can work on site logistics. How's your crane moving around the site? How are your teams laying out their material and their equipment on site? You can think about how you phase the building in construction. So thinking about doing like tilt-up concrete, huge resource for that, because if you're doing tilt-up concrete, you're laying out these huge concrete beds which take up a lot of space, right? So you're going to need to plan that space. This is a great tool for that.
Okay.
Does that answer your question?
Yeah, I was gonna
Yes.
do some contribution if I may allow, Mark.
Yes, please.
So let me share my screen for a moment.
Yeah.
There you are. And so this is I'm gonna show you a couple of things. So the first one, are you able to see this? It'll be a moment. This is loading. Here we are.
Yep, looks good.
Okay, perfect. So in this slide, Turkey, if you can see, one of the things that I was responsible for keeping control of the quality was the deliverables as far as the materials. Now, Mark mentioned concrete. That's a huge one. For this specific day, we had laid down 55,000 tons of concrete. So it was a nonstop operation over at Lackland Air Force Base. And so in order to meet the specified ASTM, you got to check on different things. So one of the things that I'm highlighting now is the air temperature. Why? Because if the concrete does not meet the temperature that's between 55 to about 90 degrees. If it goes over or under, the consistency of the material is voided. So you cannot place concrete if it doesn't meet the temperature.
So it has to be between 50 degrees to 90 degrees.
That's correct.
Right.
And so another thing is the time sampled. So in order for you to report your batch, you take so many tests on site during a specific amount of time. So you're allowed, the specifications will vary, but most of the time is from the time the concrete is placed on the dump truck to be sent to site. You have about 90 minutes to cast in place. If it's over that, then the concrete needs to be demolished and be taken out. And so with the drone, you're able to identify the temperature, not just from site, but also from above. You can also take the amount of the duration from the ground to where it's going to be placed. Also the rebar. So let me share this next image. Okay, here we are. Okay, so right here, if you notice what we're doing out there is, you see how the inspector is taking a look at the laying down and the tie-in of the rebar. So
yeah, I see.
Right here, we're five floors up in the air. So, you know, I have to access certain areas through scaffolding and through ladders. And I have to wear vest and tie-ins to secure my body to the building. And so, you know, a high possibility where a drone can come in is you can fly the drone above the wall without having him and myself, you know, just looking at those high above voids. So they have to be secured. So in this particular image, we're looking for the tolerance. So that number 5 rebar cannot be more than 1/4 of an inch close to the face of the inside of the block. So in order for you to go and actually inspect it, you have to manually go up there, and it's a little cumbersome. On the right hand side, if you look, I'm taking a slump test, which measures the amount of water and consistency of the concrete. So that's what gives the strength to the concrete. And so as I'm doing this test, I'm running up, you know, five floors up, and then coming right back down. And at the same time, I'm looking at the guys mixing the mix at the same time. So I'm trying to do 3 inspections. It would have been nice if I can fly a drone up there while I'm measuring the slump sum at the same time here on the ground. So that's one of the examples where, you know, something like a drone technology could be very beneficial. And
yeah, I'm glad to hear that.
Yeah, I can go on and on, but since you had asked that question and Mark had mentioned concrete, I said, oh, I got a couple of pictures I can show real quick. So here you go.
Yeah, it's really interesting that you know, to use drone for inspection the area instead of, you know, yourself going to, you know, the area and inspect it. Might be a little bit dangerous for you.
Yeah, you're right, and not just that. I mean, you can apply it to so many different definable features of work, like all the wells that I had to look at the structural system. So, you know, it was it was a big task, you know, having to go all the way up there and be secured with hooks to joist, you know. But you know, if you have the capacity of flying the drone and then take the picture and then you can zoom in after the fact, then you know you can still look even better with a crisp image to all the welding to make sure that it's according to the specs. And so you'd be saving yourself from, you know, getting closer to a dangerous situation, you know. So that's another good example.
Thank you so much for explanation.
Can you still hear me, Juan? Can you hear me?
I can hear you, Mark.
Yeah, good, thank you. Juan, thanks for the addition. You know, that's like twofold to me. That's efficiency and safety. So that goes hand in hand, right? As you describe that process of, you know, you got 3 different inspections going at once and your mind's all over it and you're on a busy job site, like to me, that's just a recipe for, again, that's just being on the job, right? But there's always a safety aspect too, you know. So we'd like to help with that where we can. Let me, are we doing okay, Juan, on time?
Yes, we are still fine. How are you doing over there?
I'm okay. I'm gonna pick up the pace a little bit though. I apologize I'm a little chatty on the presentations.
Yeah, no, that's fine.
All right.
Thank you.
Let's get through here. Share. Okay, I think you can see that. So yeah, you got your props or your quadcopter, hexcopter. I think some of them even have eight propellers. Those are the really big ones. Fixed wings, and then you've got your manual and autonomous. Autonomous, I like them a lot, but they're designed to be autonomous. So if you're trying to manually film something that's really cinematographic and beautiful and sporty with this, it's got capabilities to do that, but not manually. So you can hold a tracker and it can track you as you cruise down the road on, let's say, a skateboard or a cruiser. And that's really cool and all, but I haven't found a lot of value for that in construction. So I'm still working on that. So just a different tool, right? A different tool for the job that you're trying to get done. So we'll keep moving here, I think. Yeah. Again, drone deploy, again, we use a lot. Here you can see a crosshatch pattern over a job site, and use them for all types of data collection that I was showing earlier. So a couple of case studies here. This is the Burj Hotel. Oh, this is over, I forget exactly the town, but it's in Louisiana. Basically a few years back, it got hit with quite a bit of damage from a hurricane. And so they were basically going to build scaffold, as you see here, over this entire enormous hotel to inspect the damage on the face of the hotel. Luckily, we got word of that, and we said, let's not build all that scaffolding just to assess damage. Let's fly a drone across it. And so what we did is we've got all these different flight patterns, and these lines, that's where an image is taken, but they're lines upon lines upon lines, because this is now a vertical flight pattern. So you can see all those spots taken on this image on the right. And so you're basically creating, again, another map, but it's a vertical map of that face of the building. And so we were able to develop a model and images that we could assess to understand that the full extent of that damage in high definition, right? And we did that in about a day to fly it. We processed it in another day. The key thing here is the time that we saved. And I don't know where they came up with this number, but I think it cost, Juan, you might know, more than $100,000 just to build the scaffold all the way around this entire hotel. So where this 20 grand came from, maybe that's just in labor, I'm not sure, but a huge amount of time and labor saved up front by understanding the end goal, right? What is the damage to the facade of this hotel? And what is the tool to assess that? Is it a team of guys on a temporary structure that costs a whole bunch of money to build and rent? Or is it a drone that you can fly up in a matter of hours, capture that data, and then everybody gets to see a high definition version, not just the guy that's on the scaffold, right? Because don't fool yourself, your PM and your project executives are not going on that scaffolding, my friend, but they will look at some 3D models. And so you can see part of that 3D model here, and in which they were able to dig in that damage. Another case study, I just put silly image on here to make sure everybody's still awake. But talking about loops, right? Not really these kind of hoops, but hoops on the job site. So typically we're not flying drones on the interior of the building. However, when you understand the end goal, you understand the tools that you have at hand, and the process to get around those regulations, because they're regulatory and they're regular, but we're outside of that, and we can apply for a waiver. And so that's what we've done here to examine this concrete shaft in an airport in Denver. The thing that I love about this is that typically you would have a lot of difficulty getting any drone into this, because again, most drones operate on a GPS system, and most of your GPS does not want to work in a concrete cave, right? But the Skydio 3D autonomous system works off of software. So the software is telling it the distance of that wall, how far it is from the drone. And so it can calculate and say, okay, I don't want to get any closer than 36 inches or 18 or 4 inches from that. And I think that that's what we were in this image, is 4 inches from that wall. And at that point, I was extremely nervous. But if you think about it, the drone's not going to hurt the concrete wall. The concrete floor might hurt the drone, but again, there's no humans at risk here, right? Which is the key takeaway. But also, we were able to get high definition images of something that's otherwise completely inaccessible. So a good victory there for sure. And again, kind of knowing the parameters and having enough communication to get through those parameters with the right tool. And then one last case study here. This is just a small portion of a giant 200-acre job site. And you can see here that we're doing our underground excavation and trenching for just a forest of underground utilities. And part of the requirement on this job is to laser scan everything that goes underground. You're laser scanning everything that goes underground. Okay, fine, laser scanning's fun and it's really helpful. However, if that trench is deeper than 6 feet, your laser scanner has to tie off every time he goes in that trench and every time he climbs out of that trench. And so now you're talking about, again, a ton of time, right? And so what we want to do then, we want to narrow in to say, okay, client, what's your end goal with all this laser scanning? Because you might not need it. And the way we frame it is you might not need to pay for it either. And here's why. Let's look at some really dense systems, right? So we got the BIM coordinated model. Your trades, you've got a lot of electrical, you've got underground duct bank, you've got all kinds of stuff going here. Your trades have already coordinated this to how it will be constructed. So let's zoom in to some pretty congested areas like what you see here, and let's laser scan just that area. But instead of laser scanning, let's fly it with a drone and create that 3D model of the trench and the site. And so once all that is placed in here, we'll fly it, create a 3D model of it, and that's your work in place documentation or your as-built documentation. This is a really dense site. Gosh, what is this? This is maybe a couple hundred square feet, maybe 1,000 square feet. But I've got it on a really dense flight pattern. Those squares and lines are really close. We're going to go back and forth in both directions and get just a huge amount of overlap. This is 85. This is a lot. But that would be the level of detail that we would need to understand if this is going to work, right? So to fly a couple thousand square feet in 30 minutes is pretty ridiculous, but it's definitely a case study at hand. And so the theory is, and I haven't done it yet, but the theory is that 3D model from the drone would come out somewhat like the topographies do, except for you would see those utilities placed in the ground. And anytime you ever need to go back to reference, whether it is placement or objectivity, what is there, you could go back to a model similar to what you see here. So that's almost wrapping it up. Next in drones, obviously FPV is happening now. With REM technologies, we have 2 FPVs, this being one of them, and then the generation before this one. I personally, I don't know, I'm so pragmatic in construction. Like this is for cinematography and just really good looking video. In construction, meh, it's not a pretty process, man, but there's value to be had there. So I personally am still looking for the value of this. Other REM partners love flying commercial projects and making more aesthetically pleasing videos. So also a good tool, again, just what's the end goal, right? And then you've got this Leica drone / laser scanner. I saw this at Autodesk University last year. This drone runs between $70,000 and $90,000, a beautiful machine. Do I currently have the need for it? No. Would I like the need for it? Yes. But I like to say we're not there yet. I don't think, I question if the technology is there, right? Because a laser scanner is catching precise points in space, but the laser scanner itself, in this case the drone, is constantly moving at some rate, as opposed to a terrestrial land-based laser scanner. The ground's not moving, or at least not that fast, and so you can get much more accuracy. So how the technology offsets the movement of the drone itself, I'm not quite sold on.
Is the laser scanning for design?
I'm sorry?
Is the laser scanning for designing or for use it for purpose?
Yeah, so good question. You could use it for design. So again, understanding your existing conditions and taking that back to your designer and your architect and say, okay, these are your parameters. There's a wall here, there's a wall here. And there's no more guessing. Is it 90 feet or is it 95 feet? Well, actually it's 92.5 and 3/4 inch or whatever it is, right? Your laser scanner is going to give you that level of detail. But then also for documentation purposes, right? Let's say we use not necessarily drone laser scanner combo, but we use laser scanners, I think, inside of buildings all the time. Old warehouse buildings or old downtown buildings, they're going to gut out and they're going to make into, condos, let's say. We're going to get rid of everything in there except for your structure, your columns, and your floors. And that's typically all that's left over. So we'll demo it all out. We'll understand where that structure is. We'll give that back to the architects and say, here are your parameters, right? Here's your slab to slab is whatever it is, 12.5 feet. And your columns are here every 30 feet. And they're, let's say, 18 inches diameter, or whatever it is, right? So they know those parameters going into it. And there's no guessing, right? I've sat in the architect's seat, and that's the worst thing you could do is guess at an existing condition because you're not going to guess it right. Does that answer your question?
Yes, it did answer the question. But also I was wondering, do they, whoever made the drone and add this features, which is laser scanning, is it for just decoration or they use it for purpose?
The laser scan itself?
Yeah.
Yeah, that's what I'm saying. They can use it in design. So they'll take the laser scan, they'll have the 3-dimensional model. Okay. They'll incorporate
but not for
the design.
It's not for like decoration. It's for designing or
so laser scans, they're technically called point cloud models, and what that means is every point a laser it references an object in space, and so it sends that data back to the laser scanner. So basically, it's just a bunch of millions and millions of points, and so it's this foggy cloud-like thing, right? That's what the model looks like. Might not be a good description, but it tells you where things are in space. So whether it has an aesthetic appeal, probably not too aesthetic, really. Not so much for the decorative use.
Yeah, I got it. What about? Thank you.
Yeah, sure. We can take some more questions though, but wrapping up again, this is the three partners. I've known these guys for like 25 years. We went to high school together. And the guy on the left, he was the drummer of the band. I was the bass player of the band. So if y'all have a dream with some buddies, just follow it through and make it happen. We've been doing this for a while now. We're enjoying it. We've got a huge market ahead of us, and we're very excited about it. So our two goals really are to democratize aerial data capture. So any client of any type can understand what we're doing. We're not trying to do something in a box to where we have something so secretive. We want to share, right? And then the other thing is we want to provide value. This did say nonsense. We don't want to provide nonsense. So what I mean by that is we don't want to give our superintendent 500 photographs in a folder, right? He's never going to look at those and he's not going to get anything out of it, even if he did. We want to give him a valuable deliverable that he can use for his owner, architect, contractor meetings, his OAC meetings, his progress reports, his pay apps, his work in place documentation. Like he'll get value out of that, but a whole bunch of photos doesn't do the trick for that guy. So that's us, guys. That's REM Technologies. Hope y'all learned something, and yeah, I'm happy to take questions.
No question for me. Thank you.
Sure, thank you.
Yeah, yeah, I was just gonna add when you mentioned the scaffold, depending on the location and then the type of scaffolding, you know, it varies about $1.80 to about $2 a square foot. And so if you got platforms that are running, you know, 3-5 levels high, then you still have to put your handrail piping, and then your access ladders, your ramps, in addition to, you know, the safety buckles and hooks. And then if you have wheels, so all those still are adders. And so, you know, when you got a 2-3 story building, you need a scaffold, you know, it's gonna go, you know, $20,000, you know,
Easy.
roughly. So
Yeah.
it's a type of thing where right now when you were showing that rendering of the full facade of that hotel, was 5-6 story high maybe.
I think it's 10 or 12 at the highest point.
Yeah, that's a big tower, and so that's
of
also
scaffold.
some big money. Yeah.
Yeah.
And then they charge you for assembly and then taking it down, and so yeah, it quickly adds up the bigger the project is. So that's where the value will come in, as you mentioned. So just a side note.
Yeah, thank you for that.
Absolutely.
Yeah, we should get that number a little more accurate on the time and the savings there, because it's way more than 20 grand to build scaffolding all the way around that place.
Mhm.
Not to mention, like your hotel guests aren't going to want to see their hotel covered in scaffold. My wife and I went to Europe last year, and the Eiffel, part of the Eiffel Tower at the bottom was covered in scaffold. She was really disappointed. Nobody wants to see it, right? Nobody wants to pay for it either.
That's true. Yeah, that I saw that too. We were inside the Roman Colosseum. So they had a big section just covered by scaffold, and then we go to the Roman Forum, which is not too far on the other side, to go take pictures. And then the same thing, it was a whole bunch of scaffold right in the Octavian what is it? The one of the buildings. Anyway, so yeah, you see the
it'd be nice to
scaffolds.
know
It's-
that before you went to the other side of the world to see scaffolding, huh?
Yeah. I'm trying to get away from the job site, and here we go. We
You
fell
can
in.
never escape it, my friend. If you want to escape it, now's the time to escape it when you're in school, y'all.
That's true. That's true. All right.
What else y'all got? Any other questions? All right, Juan. Well, that's all I've got. Thanks for having
No,
me.
it's been great. Just
Sure, go ahead.
I might be delayed. I've got internet connection over here. Just want to say thanks again, Mark. This was really fun to learn and listen.
Yeah, thanks for joining.
Yeah, thank you for stopping by, Chris, and also, you know, if you're in the need of looking at the material from today, you know, or anybody else from St. Mary's, you know, let me know, and I'll be happy to, you know, share the file and everything. So
Be great. Yeah, I'd love that too. So I can count my ums and see where I can cut those out.
absolutely, yeah, I'll try to send that over.
Sure,
If
sure.
I have any issues with it, you know, I'll probably go drop you off a copy of the file, or we can get together, whatever. But
Very good.
yeah, for sure.
Excellent. Well, thank you, Juan. Thank you to St. Mary's for having me. Again, we love to be part of what y'all are doing. Y'all are doing so much in different corners of the university over there, and we just want to be involved with it as much as we can. So thanks so much.
Absolutely, same here. I'm excited to see this starting. You know, a lot of opportunities, and hopefully we get to do a little bit more. And you know, again, thank you for taking the time to sharing your experience and your whole operations with RM, and good luck with all endeavors.
Absolutely. Thanks, Juan. We will be in touch soon, I'm sure.
Very good. Take care.
Very
Have a
well.
good night.
Take care. Thank you.